The new approach to design, procurement, and installation for ComEd FEP projects can be broken down into 3 phases. Phase 1 involves the installation of the surrounding fence, vehicle gate with powered operator, man gate, and e-key stanchion. Phase 2 consists of the installation of all technology associated with the project, including cameras, card readers, and head-end equipment. And Phase 3 focuses on the upgrade of existing light fixtures to LED and installation of new fixtures as needed. The advantages inherent with this new phased approach include utilization of more disadvantaged business enterprise companies, whose expertise tends to be very specific, a reduction in the amount of tiered subcontracting required and their associated fees, and flexibility to accept future iterations of the technology requirements. We'll further explain the approach specific to each of the 3 phases by breaking down each phase into 2 parts: the scope of design documents and the method for procurement and installation. Phase 1 design development scope will include a new 12-foot fence with 6 strands of barbed wire at the top in place of the existing fence. The new fence will be grounded to the existing grounding system. Civil work will be limited to areas where grades under the fence need to be adjusted to mitigate access. New power-operated vehicle gate will be designed with concrete apron and all associated safety sensors. The new vehicle gate will be integrated with e-key access utilizing a new dual-height card reader stanchion, maintaining current operating procedures for site access, and a new man gate will be installed in accordance with the FEP requirements. Finally, a new home run will be installed from the control house to the gate operator, along with spare raceways for future power and technology, terminating on the new fence for ease of access. Because of the reduced design requirements, this work can be treated as a typical fence installation requiring only circuit selection for the motorized gate operator, regrounding of the fence, and e-key to motorized operator interface. The second part of Phase 1 is the method for procurement and installation. Utilizing the highly accurate 3D model and 2D drawings along with a cost schedule, contractors will be engaged in a factored bid approach, otherwise known as job order contracting. Job order contracting involves the development of a schedule of values with budget numbers that will be issued to bidding contractors. The contractors will use a factoring approach to adjust each scheduled value up or down to achieve their proposed cost. Additional areas will be made available on the bid sheet for any items that they feel the documents do not address. This method of contractor procurement will be utilized for all 3 phases of the project. Phase 1 contracts will include a fence installer, civil contractor is required for grading to remove gaps under the fence line, and an electrical contractor for installation of the electrical power for the gate operator and spare raceway for future power and technology needs. During the installation process, all the installations will be captured in an as-built model. The owner will operate as an owner-builder and direct work to the subcontractors for specific scopes. This approach can increase the utilization of disadvantaged business enterprises for contractors with specific skill sets as Tier 1 contractors. An alternate and more traditional approach is utilizing a single contractor of choice to subcontract all the scopes of work. However, this typically results in an increase of overall fee. Phase 2 design development scope involves the technology design and will follow the most current revision of the FEP technology's requirements. For example, Revision 9 Tier 2 sites will be designed to include but not be limited to the following considerations. The terminal box and conduit installed on the gate during Phase 1 will be utilized to run wire for gate contacts. The e-key mounted on the dual-height card reader pedestal will be swapped out for a new card reader at both the upper and lower pedestals, and a new camera will be installed monitoring the main motorized entrance gate. A minimum of 4 fixed cameras and up to 2 infrared PTZ cameras will be installed at the exterior of the control house, with coverage to the interior of the yard. Additional cameras will be installed at or near critical assets as defined by the owner personnel. Fixed cameras will be located on the inside of the control house and are intended to monitor switchgear and security panels. All entrance doors to control houses will be monitored by the interior and exterior sides of the door with new cameras. All doors and entry points, for example roof hatches and roll-up doors, into the control house will have door contacts. The control house will have cameras and motion sensors strategically placed and validated by the owner, with request to exit sensors also installed at each door. This phase of the project will involve 2 designers, a technology designer and an electrical engineer. The technology designer will be engaged as part of Phase 2 to design the camera layout, door contacts, and related head-end equipment and associated cabinets. The electrical engineer will provide design of the power for the technology equipment. The procurement and installation approach for Phase 2 will utilize the job order contracting method similar to that of Phase 1. Phase 2 contracts will include an electrical contractor for installation of new security devices and head-end equipment, and a security integrator to integrate and configure the security system in accordance with Corporate Information Security Services standards and turn over to Exelon Security Operations Center. During the installation process, all the installations will be captured and documented in the same as-built model developed as part of Phase 1. The owner again will operate as an owner-builder and direct work to the subcontractors for the specific scopes. The final phase of the project is the design, procurement, and installation of site lighting. The design development scope starts with replacement of the existing site lighting within the 3D model with new, more efficient LED fixtures. By modeling the light fixtures within the 3D model, the lumens can be simulated for better visualization of the effects of the new lights. During review with the responsible parties, the model along with the photometric calculations are used to determine if additional lighting is needed. Additional lights are then placed into the 3D model and lighting simulations updated so that the changes in illumination can be further visualized. All changes are checked against the photometric calculations. Phase 3 will involve an electrical designer for the design of the new circuits for added strategic lighting, conduits, and photometric calculations to incorporate existing lighting to the new LED design. As with Phase 1 and Phase 2, the 3D model and 2D drawings along with the cost schedule will be issued to bidding contractors and bids submitted using the job order contracting approach. Phase 3 contracts include an electrical contractor for installation of new lighting circuits and replacement of existing fixtures with LED. During the installation process, all the installations will be captured in the as-built model previously developed in Phase 1 and Phase 2. And, similar to Phase 1 and Phase 2 approaches, the owner will operate as an owner-builder and direct work to the subcontractors for the specific scopes, reducing second-tier fees and allowing for carve-out of locally sourced disadvantaged business enterprise contractors and carve-out of locally sourced material and equipment manufacturers. This phased approach will also open up opportunities to employ ComEd electricians on preferred work scopes such as grounding, pulling of cable, conduit installation, and mounting of fixtures.